Okay, we're on lesson 6. This is adding whole numbers. Again, sounds like baby stuff. I want you to understand the place value behind it, how to use money, how to transfer from ones to tens to hundreds. So, and it's tons of vocab. So let's go not too slow because it is pretty easy, but let's get the ins and outs down pat. Okay, so first thing they want you to know is what an addend is. So it's any of the numbers added in an addition problem. And then the sum is the answer to an addition problem. So 3 plus 4 equals 7. There's an addend, there's an addend, there's the sum. So easy enough, right? The commutative property of addition tells us that we can change the order of the addends, and it doesn't change their sum. So I can say 5 plus 6 is 11, or I can say 6 plus 5 equals 11. When I think of commutative, I think of like commuters going to work. You know, sometimes they're at home, sometimes they're at work. So they can change places between home and work when they commute. So commutative is just changing places. So that's what that means. The next thing they want you to do is they want you to add 6, 3, and 4. Again, first grade stuff. But they want you to think about it a little bit differently using the commutative property. So I can make any order I want. I can do 6 plus 3 plus 4, 6 plus 4 plus 3. They're all going to equal 13, right? So what they want you to do is look at a list of numbers if you have a longer list to add. Try to find compatible numbers, numbers that add up to something easy. So I'm going to look at this list. I'm going to say, oh, I know 6 plus 4 is 10, and then I can just slap that 3 on the back. So 6 plus 4 equals 10, then 10 plus 3 equals 13. You can do 9 plus 4, but sometimes adding things to 10 is just easier. Again, all of these work, but they're trying to give you hints to work a little smarter and not harder. So let's look at example 1, and it says find the sum of 7, 4, 3, and 6. Oops, put my paper under all the dots that the Sharpie mark makes. So I'm going to look for compatible numbers that maybe add up to 10 or add up to something I know how to do easily. So I know 7 and 3 equals 10, and I know 4 and 6 equals 10. So then I can just say 10 plus 10 equals 20, right? I can do it this way. I can say 7 plus 4 equals 11, and 3 plus 6 equals 9, and 11 plus 9 equals 20. But if I can rearrange these a little bit, it makes it a little bit easier. So think about that when you're adding lists of things. Again, you don't have to. It just makes your life a little easier. Okay, example 2 says justify. So justify means show me why something works. So the question is, 4 one-digit numbers are added. Is the sum more or less than 40? How do you know? Okay, so let's think about that. I have 4 one-digit numbers. So 1, 2, 3, 4, 5, 6, 7. Let's pick the biggest one, and we'll see if it's more or less than 40. So 4 one-digit numbers. So 9 plus 9 plus 9 plus 9. So if I have those 4 biggest one-digit numbers that I have, and I add them up, I can multiply, can't I? 4 times 9 is 36. So I know the sum of this problem is going to be 36. So I can't make 4 one-digit numbers any greater than 36. That's the biggest I can make it. So I've justified right here, because I've shown why it works, that it is always going to be less than 40, right? They also told you that the identity property of addition tells you that any number plus 0 doesn't change its identity. So 2 plus 0 is 2, 999 plus 0 is 999. Anything plus 0 doesn't change. So that's a good vocab word to remember. That'll come in really handy when you get to algebra, so you do have to know that. Then they start talking about algorithms. So algorithms are just a certain way, a procedure that we use to get an answer. Believe it or not, there are a bunch of different algorithms for multiplying numbers. There's a bunch of different algorithms for dividing numbers. Addition, it's not quite so many different kinds, but there are some different ones. Saxon Math, we're going to talk about the way that they use an algorithm. So their example, Jamal had $462. Okay, so here's Jamal's $462. Okay, and then Maria paid Jamal some rent. So she paid $58. Okay, so here's $58. So we're going to add this on. We're going to put the 50 there and the 8 there. So now they want to know how much money Jamal had. So I'm going to count the ones first. Okay, so let's see how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can I change that into a 10? Sure, let me go to my Monopoly Banker money. I could change that to a 10. Now let's count the 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Can I change that into 100? Sure. Okay. So put that over there. Now let's count my hundreds. 100, 200, 300, 400, 500. So did Jamal have $520? Yeah. Now I could also use all those ones and tens, but isn't it easier to group them and then change them into something that's a little bit less fat wallet, right? So we're going to do the same thing here. We're going to start with the ones because that way I can change things. So I'm going to carry, I'm going to say, oh, I have 10. I'm going to carry that 1 to the tens. So I have now 0 ones, but I have an extra 10. So I have 7 plus 5 is 12. And I'm going to carry that because I also, it's telling me now I have 2 tens, but I have an extra 100. So 1 plus 4 is 5. So that's how place value works. And that's what we mean when we say we're going to carry that. It just means we're changing those extra ones or extra tens into the next highest place value, right? So that's pretty easy. So we can exchange even if we're just doing it on paper instead of with Monopoly money. Again, review. When we get to about lesson 15, I think things will start picking up. I do want you to know those vocabulary words. So make sure you put those in your notes if you're taking notes. Okay, so that was lesson 6.